In this video, we'll take up the homework for graphing transform sine and cosine functions. We're looking at 10 functions here, and the strategy for pretty much all of them is the same. Maybe I can argue for the first 4 examples. They're a little different, but they're very, very similar. So why would I argue the first 4 examples, the first 4 questions are a little different? Is because for the first 4 examples, d is equal to 0. So to scale the vertical axis, I need the max value, the min value, and the c value. So the max value can be found by taking c plus amplitude. Min can be found using c minus amplitude. So those 3 values will scale the vertical axis, will help me determine the scale for the vertical axis. And to scale the horizontal axis, I need to know the period, which is found using the k value, 360 degrees over k. And then I find out what a quarter period is, because that's the spacing between my key points, my max, my min, and the values on the equation of the axis. So in this case, the quarter period is 30 degrees. So that's why the spacing between my key points here is 30 degrees. So because d is equal to 0, I'd argue that questions 1 through 4 are relatively straightforward. Okay. So number 2, same idea here. Quarter period is 45 degrees. For number 3, quarter period is 30 degrees. And number 4, quarter period is 22.5 degrees. Okay, number 5 is when it gets interesting. So d here is negative 70 degrees. And the quarter period is 30 degrees. The greatest common factor between 30 and 70 is 10. And that is what I will use to scale the horizontal axis. Why is that a good idea? Because if I scale it as 10 degrees for my horizontal axis, now every single key I plot will be where the grid lines intersect. Okay? Because the first point I plot will be where the grid lines intersect, and each subsequent one will be where grid lines intersect, because in this case 30 degrees, that's 3 blocks, right? As long as the quarter period is a multiple of what you choose as your horizontal axis, then it's where the grid lines intersect. Of course, we have to first start off where the grid lines intersect, and every subsequent key point will also be where the grid lines intersect. Okay, so that's a logic behind why we want the greatest common factor. That will ensure the first point is where the grid lines intersect, and where the subsequent points will be where the grid lines intersect. All right, question 6. So you'll see that the greatest common factor between the quarter period and the horizontal shift is 15. All right, so there we go. Not much to say. Question 7. Let's see, what do we have here? Yeah, nothing special. Nothing special. So just a quick refresher though, these 5 points, when I graph them, they look like a sine function that's been reflected across the x-axis, and that's perfect. That's exactly what I want to see, because it's minus 2 sine whatever. So anyways, I know that if I plot the 5 key points, I should get a sine function or something resembling of a sine function that's been reflected across the x-axis. Okay, let's see, what do I have for 8? 8 is, okay, so 8, hold on a second here. 8 is quarter period is 22.5, and it's 70 degrees. So the thing for 8, okay, yeah, that's what I want to say. For question 8, I didn't scale it, that's the horizontal axis, properly, because the quarter period is 22.5 degrees and the horizontal translation is 70 degrees to the left. So between 22.5 and 70 degrees, or 2.5 and 70, I'll let you think about it. But the greatest common factor is not a very friendly number. It's 2.5. The greatest common factor is 2.5. That is atrocious. That's horrible, because that means each block is 2.5 degrees, and I just didn't want to kill enough. I didn't want to kill my trees. So you know what? I'll let you use your imagination. But if you want, you can scale it using 2.5 degrees if you want every single point to be where the grid lines intersect. So because I didn't 2.5 degrees, you see some of these points are not where the grid lines intersect. Yeah. All right, question 9. Question 9 was friendly. Yeah, 90 degrees shift to the right, 30 degrees quarter period. So yeah, the scaling is very nice. All right, last one. Okay, for question 10, not very exciting. It's pretty straightforward. You have a quarter period 30 degrees, a horizontal shift of 10 degrees to the left. So the numbers are very friendly. I'd argue the real problem in this, not a problem, but the most complicated question is number 8, and it's not really complicated because the math is challenging. It's just because the scaling is not very friendly. We're very, very unlikely to do that on a quiz or a test situation because it's not complicated. It's just we're just killing the trees unnecessarily because I do want the key points to be where the grid lines intersect. So as long as you know the general shape of the sine function and cosine function, and of course having the key values here, you can scale the axes properly and you should be able to graph your transform sine and cosine function.